good morning. Welcome to online learning standard 11 subject chemistry. Dear students, in 11th standard chemistry, we have been discussing unit number 1, that is basic concepts of chemistry and chemical calculations. And in this unit, we have completed about the first concept, that is matter around us. What is called as matter, how it is classified, and their types. Everything we have seen in the previous video. And in this video, the concept which we are going to discuss is atomic and molecular mass. Okay, so this is the concept of today's video. Let us move on to the video. Okay students, look at the picture given. What I have taken a picture of an apple. Okay students, if you are asked to find out the weight or the mass of this apple, how can we do it? Yes, we can find the mass of this apple by using this weighing balance, isn't it? Yes. Okay, so this is a simple way of measuring the mass of a particular object. But in the same way, can we measure the mass of an atom? Is it possible? No, it's not possible, because the atoms are very tiny particles. We cannot even see them with our normal eyes, isn't it? Yes. So, for measuring the mass of an atom, we need a special method. Surely we have to study about the mass of an atom, but we cannot measure their mass directly by using a weighing balance. So, there is a special method is necessary in order to measure the mass of an atom. Dear students, first we have to know about some basic information of the atom. Okay, atoms possess the diameter of about 10 to the power minus 10 meter, and their mass is approximately 10 to the power minus 27 kilogram. So just imagine and see, with this small size and small mass, can we able to measure directly? No, it is not possible. We cannot measure the mass of an atom directly. So it is given here. Atoms are too small. They are very tiny particles. So their mass cannot be measured directly. We cannot measure the mass of an atom by using this weighing balance. Okay, so now we are going to see how to measure the mass of an atom. Okay, so it's given here. For measuring the mass of an atom, a relative scale is proposed. Relative scale is nothing but we have to use a standard atom, and the standard atom is the one whose mass is known. Okay, so that is given in the next point. A standard atom is taken and whose mass is known. Okay, so for measuring the mass of an atom, we have to use a standard atom, and the standard atom's mass is known to us. Okay, then the question is, which atom can be used as a standard for measuring the masses of various atoms? Then the answer was given by IUPAC. We know about IUPAC. What is IUPAC? International Union for Pure and Applied Chemistry. So the IUPAC has considered the atom of carbon as the standard atom. So carbon 12 is considered as the standard atom by IUPAC. That is given in the point number 3, C12. Here C12 is carbon 12, and it is considered as the standard atom by IUPAC. So it is also called as standard as well as reference. So with reference to this carbon 12 mass, we have to find the masses of the remaining atoms. Okay, and the mass of carbon, this carbon 12 is 12 AMU. Okay, dear students, what I have told you, the atoms are very small, so that their mass cannot be measured directly. So we need a relative scale, which means a reference atom is required, and the reference atom is carbon 12, which is proposed by IUPAC, and the mass of carbon atom is 12 AMU. Okay, and this unit is new to you. AMU is new for us because you may not have an idea about AMU. What is called as AMU? Dear students, the expanded form of AMU is atomic mass unit, or we can say unified atomic mass. What is AMU? Atomic mass unit, or it can be called as unified atomic mass. Now we are going to define what is called as AMU. The definition is given here. AMU is defined as 1/12 mass of the carbon 12 atom in its ground state. Can you able to understand? We know the mass of carbon 12. So out of the total mass, it is the one part of the 12th of the carbon 12 isotope. அதாவது கார்பனுடைய நிறையில் 12இல் ஒரு பங்கு. Okay, so it is the 1/12 of the mass of carbon 12 atom in its ground state, and the value of 1 AMU, that is equal to 1.6605 into 10 to the power minus 27 kilograms. So this is the information we have to know about AMU. Okay, what is unified atomic mass? It is defined as the 1/12 of the mass of carbon 12 atom in its ground state. Is it clear, students? What is the value of 1 AMU? 1 AMU, that is equal to 1.6605 into 10 to the power minus 27 kilogram. Okay, what is selected as a standard atom? Carbon 12 is selected as a standard or reference atom. Okay, now we are going to see relative atomic mass. Okay, so atomic mass we know, at mass of an atom. Then relative atomic mass, in the sense we are relating the known mass with unknown mass, no? So the atomic mass is modified into relative atomic mass, and scientifically it can be defined as, the definition is given here. It is the ratio of two terms, and those two terms are, it is the ratio of average atomic mass to the unified atomic mass. The relative atomic mass is the ratio of two terms, and those two terms are average atomic mass and unified atomic mass. About unified atomic mass we know, just now we have seen what is called as unified atomic mass or atomic mass unit. Now which is new for us? The term average atomic mass is new for us, so that we have to define what is called as average atomic mass. That I will show you in the next slide. Okay, so what is relative atomic mass? It is defined as the ratio of average atomic mass of an atom to the unified atomic mass or atomic mass unit. This is the definition of relative atomic mass. Okay, and this relative atomic mass can be represented by the symbol AR. Here R is a subscript. Okay, the relative atomic mass has the denotation of AR, which is equal to average atomic mass divided by AMU. The definition is given in the form of an equation. So relative atomic mass, that is equal to average atomic mass divided by AMU. This is the formula of relative atomic mass, and this relative atomic mass is explained by considering an example of hydrogen atom. Now we are going to calculate the relative atomic mass of hydrogen. Okay, so in order to calculate the relative atomic mass, what are the things we need? We need two things. What are they? One is average atomic mass, and the one more is unified atomic mass. About unified atomic mass value we know, it is a constant 1.6605 into 10 to the power minus 27. Just now we have seen about it. Okay, and average atomic mass is already given. The average atomic mass of hydrogen is 1.6736 into 10 to the power minus 27 kilogram, and AMU, that is equal to 1.6605 into 10 to the power minus 27 kilogram. Now we can substitute both the values in this equation. So AR, that is equal to 1.6736 into 10 to the power minus 27 kilogram divided by 1.6605 into 10 to the power minus 27 kilogram. So when we divide these two values, the answer will be equal to 1.0078, and when it is rounded up, the answer will be equal to 1.008 U. Here U is the AMU, atomic mass unit, can be simply represented as U. Okay, so this is the way of calculating the relative atomic mass. How to calculate? If you know the values of average atomic mass and unified atomic mass, what can we calculate? We can calculate the relative atomic mass of an atom. So once again, let me tell you what is called as relative atomic mass. It is the ratio of two things. What are they? One is average atomic mass. So it is the ratio of average atomic mass to the unified atomic mass, and by using this term we have calculated the relative atomic mass of hydrogen atom. Okay. Then in the previous slide we have used the term average atomic mass. As I told you, it is a new concept for you. Average atomic mass, we haven't studied it, so we have to think of it. What is called as average atomic mass? Dear students, every atom possesses a number of isotopes. You know about isotopes. What is called as isotope? Atoms of the same element with same atomic number, but what is different? The mass number is different. So they are called as isotopes. So each atom of isotope possesses various masses. For example, if you take hydrogen, it has three isotopes: H11, H12, H13. So here the atomic numbers are the same, but mass numbers are different. Okay, but in this case we'll get a confusion. Which mass we can take? We can take the mass 1 or 2 or 3. So in such cases, if an atom possesses a number of isotopes, then we have to find the average of the masses by multiplying with their percentage of abundance. For example, this H11 may present 60 percentage, then this H12 may present 20 percentage, next also will present in 20 percentage. So based on the percentage of relative abundance, we have to calculate the average atomic mass that we can see now. So what is average atomic mass? Every atom possesses some isotopes, and we have to find the average of the masses of such isotopes. That will be equal to average atomic mass. By definition, it can be defined as the average atomic mass is the average of the atomic masses of the isotopes of an atom. That is called as average atomic mass. And here the average atomic mass of chlorine is calculated. Chlorine has two isotopes. What are they? Chlorine 1735 and chlorine 1737. Here the mass numbers are different. The first isotope possesses the mass number 35, whereas the second one possesses the mass number 37, and their relative abundance is also given. Chlorine 35 isotope is present as 77 percentage, and chlorine 37 is in 23 percentage. So by using all these informations, we can calculate the average atomic mass. Here what is the mass number? It is 35. So 35 into 77, the mass number into its percentage abundance. Then here the mass number is 37, and here the percentage abundance is 23. So 37 into 23 divided by 100. In order to calculate average, we are dividing this term by 100, and the answer will be 35.46 U, or when it is rounded up, it will be equal to 35.5 U. You know what is U? U is the unified atomic mass or atomic mass unit. Okay, so this is the way of calculating average atomic mass. How to calculate? The mass number has to be multiplied with its percentage abundance, then divided by 100, so that we can get the average atomic mass of an atom. Okay, so with this, atomic mass is over. Okay, so what are the things we have seen? The mass of an atom cannot be measured directly, so we need a relative scale, and we have to use a reference atom. By IUPAC, the carbon 12 is considered as a reference atom. The mass of carbon 12 is known to us, that is 12 AMU, and we have defined AMU. Then a relative atomic mass is proposed. It is the ratio of two terms. What are they? One is average atomic mass, and one more is unified atomic mass. If you know both these things, if you know the average atomic mass and unified atomic mass, then you can calculate the relative atomic mass. Then what is average atomic mass? Every atom possesses a number of isotopes. So in order to avoid confusions, what we have to do? We have to find the average of the masses of all the isotopes of an atom, and that mass will be equal to average atomic mass. Okay, and here we have calculated the average atomic mass of chlorine atom. Okay. Okay, then next we are going to discuss about molecular mass. Dear students, we know how molecules are obtained. Can you tell me how they are obtained? The molecules are obtained as a result of the combination of atoms. When two or more atoms combine, what do we get? We get a molecule. Okay. Then for calculating the molecular mass, it's very simple. What we have to do is we have to add the masses of the atoms present in a molecule, so that we can very easily get the molecular mass of a molecule. Is it clear, students? How to get the molecular mass? We have to add the masses of the atoms present in a molecule, and when we add the masses of the atoms, what do we get? We get the mass of a molecule. So by definition, it is given here. It is the sum of the atomic masses of the atoms present in a molecule. And for illustrating this, I have taken two examples. One is a water molecule, and the one more is carbon dioxide molecule. What is the formula of water? H2O is the formula of water. It possesses, what are the atoms? it possesses 2 hydrogen atoms and 1 oxygen atom. Okay, and to know the masses of hydrogen and oxygen, we can refer the periodic table. Okay, and these are very simple atoms. No, we know the mass of hydrogen atom. What is the mass of one hydrogen? That is 1. Okay, so the molecular mass of water molecule will be equal to atomic mass of hydrogen plus atomic mass of oxygen. How many hydrogens are there in this formula? There are 2 hydrogens, so we can write 2 into 1. The mass of one hydrogen is 1. Since we have 2 hydrogens in water molecule, it has to be multiplied with 2. So 2 into 1 plus, how many oxygens are there? Only 1 oxygen. What is the mass of oxygen atom? It is 16. So 1 into 16. 2 into 1 plus 1 into 16, that is equal to 18U. Okay, so this is the way of calculating the molecular mass of a molecule. Okay, so for H2O, what is the mass? 18 is the molecular mass of water molecule. In the same way, we can calculate the mass of carbon dioxide molecule. Here, what are the atoms present? 1 atom of carbon and 2 atoms of oxygen. That is given here. The molecular mass of CO2 is equal to atomic mass of carbon plus atomic mass of oxygen. How many carbons are there? Only 1 carbon. What is the mass of carbon atom? It is 12. So we have written 1 into 12 plus oxygen. How many oxygens are there? 2 oxygens, and the mass of one oxygen is 16. So 2 into 16, and totally that is equal to 44. So 44 is the molecular mass of carbon dioxide molecule. For water molecule, the mass is 18, and for carbon dioxide, the molecular mass is 44. And by using the same method, we can calculate the molecular masses of whatever the given element is. Okay, students, with this the video ends. Go through the video and learn well. Thank you.